Um, Good morning, everyone. My name is Iti van der Walt. I am from the Agricultural Research Council in South Africa. I am part of the Plant Health and Protection Research Institute, and I'm from the Pesticide Science and Impact Division. We've been working on Quelea birds for a couple of decades now, under the South African scenario, and together with Professor Bob Cheek in Botswana as well as in Tanzania. And I've been requested to give a talk relating to our experiences in South Africa, as well as what we have observed in Botswana during the research studies that we've done, as well as that in Tanzania. As you know, Quelea is an endemic bird in Africa. It occurs in 19 countries, and there are 3 subspecies on the northern part of Africa and sub-Saharan Africa. The Quelea subspecies is found, and along Ethiopia and Tanzania, the subspecies is Ethiopia, and in southern Africa and the SADC region, the Quelea lathimii subspecies is found. Very interesting, at the bottom of the screen, there's a little loop. So that is a recent range expansion of, just incidentally, of the red-billed Quelea into the Western Cape, and that follows the Orange River. And the reason for overwintering populations in this area is that there are now center pivot winter wheat being cultivated in the area. So we believe that the range has expanded into that area because of the food supply that's available throughout the winter in South Africa. Okay, as we know, Quelea are a predator of small grain crops right through many countries in Africa. They can occur in extremely large flocks. This is an example of billet that's been predated in a small-scale farmer homestead in Dodoma in Tanzania. And as you can see, the ears are 50% or more predated. So for the subsistence farmers, they can really suffer huge or tremendous personal losses and food security due to Quelea. Even though the agricultural practices are excellent, and there's a lot, there's good phytosanitary practices being made, and yeah, they can really be devastated by the attack of Quelea. Okay. This is just to show the different color schemes and breeding plumages of the red-billed Quelea. It differs slightly from the Ethiopia subspecies, and that some of the markings are slightly different, and it takes a trained eye in order to discover that. The current practices, this is an aerial, a ground-based application of fenthion in Botswana. So they're using a Micronia AU 8000 spray head, and one of the requirements for that is that they have to cut swaths through the thickets of thorn bush and sickle bush in order to spray the Quelea using ground-based application methods. And they're using the 64% BLV formulation of fenthion. They're also, in South Africa, predominantly it's sprayed by aircraft late at night, and the aircraft flies over the roosts or breeding colonies at night, and the noise of the airplane actually creates the stimulus for the birds to fly up, and it flies into the plume of pesticide that was deposited above the site. One of the drawbacks, or one of the severe drawbacks of chemical pesticide control, is the fact that there are what's left afterwards is a lot of poisoned carcasses. Now, according to law by the Department of Agriculture and Rural Development, the farmers who derive benefit from the control action have to provide the labor to collect those carcasses and to bury them. Not to burn them, but to bury them. But we do know of instances where the laborers actually go and eat the contaminated carcasses. So much so that we had a MRC study, Medical Research Council study, to look at the cholesterol levels of those farm laborers who actually consume it. And what we did discover is that both the acetylcholinesterase and butyryl or plasma cholinesterase levels were depleted up to 40%. So that is just shy. That is still a chronic toxicity effect, and it's just shy from acute toxicity, where you actually get the overstimulation of your neurological pathways of the cholinergic fibers, like difficulty in breathing, muscle cramps and spasms in the lungs and in the heart, etc. So the problem with the carcasses is that really creates a very, very severe scenario for secondary poisoning. And we've also investigated instances of tertiary poisoning. So based on the cropsies that we've done on raptor bird species that we've discovered that are dying many kilometers away from the sprayed Quelea site, the necropsy showed that they have the remains of Quelea in their crops. And when we analyzed those crop contents, we discovered that they had high levels of phenthine. What we also discovered was by analyzing the feathers for phenthine, one can determine if it was primary poisoning, that is, if it was directly sprayed onto the raptor birds that were in the vicinity of or inside the spray area, and as well as comparing that to levels in the crop, one can make the distinction between secondary and primary poisoning in the cases. So the quality control has really resulted in severe environmental disasters where hundreds or more raptor bird species, black kites, yellow-billed kites, steppe buzzards, etc., have been killed. So it's really an important thing to look at the carcasses after phenthine application. Okay, what we do during our studies is we use the test-made cholinesterase analyzer. So we are able to do plasma and serum cholinesterase analysis in the field, and we get results within 2 to 3 minutes. So the assay is battery operated. So one takes all of the little vials into the field, and one measures from the phlebotomy that's performed on whatever on-target organism, including birds and mammals. We use 10 microliter capillary tubes in order to ensure that we have a good liquid handling practice in the field. The only difference between the mammal analyzer and the bird avian analyzer is that the bird analyzer requires the test-made analyzer to be heated by means of additional batteries to 42 degrees, because that is the optimum temperature of birds, the body temperature. In humans and livestock, we get good results and comparisons with pathology laboratories. And in some of the rodents, the butyryl cholinesterase is differently partitioned in the blood system. So not all species will give you a butyryl cholinesterase reading, but you do find the acetylcholinesterase, the plasma analysis, you do get results. So the results have shown that even weeks after fentanyl applications, the levels in non-target species in mammals and birds remain low for up to 3 months after application. The plasma cholinesterase rejuvenation, or the turnover, the hemopoiesis, normally takes about 72 days in most mammals to complete. So there is a consistent long or medium term effect on non-target species as far as the plasma cholinesterases is concerned. The serum cholinesterases are the ones that are of concern. It also reacts much more quickly to organophosphate pesticides, and when the serum cholinesterase levels drop to almost 0%, it immediately starts the onset of acute toxicity, where the all the physiological functions being governed by cholinergic fibers are affected, and that eventually leads to death. Okay, the organophosphate pesticides are considered highly hazardous chemicals. So if we look at the risk model, the risk is equal to the hazard of the chemical times the exposure. And as we know, the pesticides, especially organophosphates, can cause delayed neurotoxicity, can cause teratogenicity, can cause endocrine disruptive effects. So that especially in male reproductive health of young infants, it can be quite devastating. It is definitely non-toxic to non-target organisms, both terrestrial and aquatic. It can cause mutagenicity and other factors as well. So when we're looking at alternatives to Quelea control of the use of fentanyl, excuse me, those agents or processes or methodologies must have some kind of target on the sensory physiology of Quelea. So they can be grouped into those alternatives that would affect sight or hearing or touch. It can affect the smell or taste, or it can have a direct or indirect physical or mechanical effect on the Quelea to prevent them from predating on small grain crops. So I'll just run through some of the different categories that they can be grouped in. One can get lethal and non-lethal alternative control methods. They can be either physical, that is from trapping and nest harvesting and bird scaring, like in the case of the using of falconry to dissipate the birds, which will be discussed by the presenter in the next talk. And it can be chemical, that is the non-dependent pesticidal chemicals. It can be explosions, it can be repellents, it can be physical sticky chemicals or substances, etc., that can be employed, or they fall into those categories. One of the methods of scaring is obviously then affecting the bird's hearing. So that's the use of gas cannons, as well as other noise-making devices. But each of these devices do come with some limitations on its efficiency and its efficacy. So you do get multi-directional gas cannons that can be employed, but it might be effective for the smaller scale farming production systems, but on commercial scale production systems, one would need, when you're looking at areas of 500 hectares to 1,000 hectares under winter wheat, it becomes less effective. And we also see a very quick habituation to the noise. So the farmers always joke and say that Quelea become deaf. That's why they're getting closer. But it's just a case that they become used to the cannons going off, making the loud noises, and they start feeding within 20-25 meters of the noise, as if nothing is going on. Then there are obviously other noise-making devices that are used very often in Tanzania. So this is a rope system where children during the Quelea season are standing on the roofs and they pull the strings. So what you see there is that's a tin that has stones in them. So when they pull and they agitate the tin, it starts making noises. So this is very effective on small scale subsistence farming areas, and they do succeed in preventing 95% of the damage. One of the drawbacks is this is very, very labor intensive, and it also has a socioeconomic cost in that the children have to be at the homestead, and they are normally used in their duty or the chores is to prevent the birds from eating their crop, and then they miss school and they miss all of the other social integration in the community. So this has a long-term socioeconomic cost by using this method, that it is employed quite widely in Tanzania in subsistence farmer homesteads. Okay. One of the other methods also, this is a whip that is being cracked by a boy on top of the roof of a hut. It makes a very, very loud noise, and it succeeds in repelling or dissipating the Quelea that is attacking their crop. It's made from baobab bark fiber, and it's woven together into a very effective whip. But again, it's very labor intensive, and it has a severe socioeconomic cost to families under those production systems. Okay. One of the other methods is a combination of physico-chemical. In the case of fuel explosions, in South Africa, 60% or so of all control operations are performed by area application of phenthine, and wherever those areas are close to water or in a sensitive ecological area, the decision is always to rather go for fuel explosions. So fuel explosions comes with their own environmental effects, and it normally the way they do it on the bottom right hand side is the blue wire is the Cordex detonation cord. It is tied around two, in this case, it is magnum busted Joule explosives. And on top of that, they place a 25-liter drum that is normally filled with 15 liters of fuel. And in this case, it will be petrol. And they have to do almost 400 bomb stations per hectare in order to get sufficient mortality of the Quelea. But obviously there's a lot of destruction of the habitat. Niches are also destroyed, and where there are invertebrate eggs that may not have been affected by chemical, they are burned during the process of the fuel explosions. So it's up to 2,000 liters of fuel that is exploded per hectare. And one of the limitations is it cannot be used over very, very large areas. And normally about 5 hectares or less that can be used. It does cause a lot of organic petrochemical pollution, and those petrochemicals actually remain in the soil and on plants for a very, very long time, longer than some of the pesticides. And you also see a lot of the plastic drums. It's a low density polyethylene drum. So those plastics also burn, and they also create pollution that can last for a very, very long time. One of the other things is also sometimes the trees are destroyed if it's at the time of the year when the apical meristems are busy actively growing on trees. So it actually does destroy the remaining agroecological systems. So on average, the farmers are not very worried about agroecological systems, but we have shown that we have found in surveys that we've done for biodiversity in controlled sites and uncontrolled ecological areas, the explosions obviously only occur, or the control actions only occur in natural vegetation or thorn bush thickets, where they represent the last refugia of remaining biodiversity in the intensively commercial cultivated areas. I just want to also just mention, because of the rapidity of the explosion, there's very little leeway for any non-target birds or mammals to escape the explosion. So everything that is there is killed, and we do find a lot of non-targets. We also had an environmental disaster where not enough due diligence was performed by site inspection, and in one case on a 3/4 hectare area, 144 black-shouldered kites were killed during an explosion. So the ornithologist at the Endangered Wildlife Trust indicated it will take more than 40 years to replenish that loss on biodiversity in the raptors that were killed. So, and also, strangely, after that, not long after that, the next season, that area had a rodent problem. So they had a rodent plague in that area, close to Westminster and Tabanshu. It's close to the border of Lesotho. Okay. Explosions actually create large craters, and they do affect rodents, not only those that are immediately killed by the explosion, the force of the explosion, but it also collapses tunnels, etc. And you get rodents like elephant shrews and shrews, which are considered wildlife, that are also killed during the explosion control operations. Okay. One of the methods that is employed a lot in Tanzania is mechanical harvesting and destruction of nests. You get the villagers and the community going into the thickets, especially obviously only in breeding colonies, where they harvest the nests, and they destroy the nests, and they harvest the chicks inside the nests. Okay. They can actually get a lot of protein from that. So this is just from one site. There were 17 people. They had different buckets and 2 or more buckets each, and sometimes also those 40-kilogram woven plastic bags that are normally used for maize or meal, and they get eaten. At the site itself, we see the practice that they collect the birds, they start a fire, and they throw the chicks directly into the fire and onto the coals, and within minutes it's ready to be eaten. They just squeeze out the gut, and then they consume the rest of the bird. Okay, one of the methods that has also been investigated by Professor Cheek is the use of traps. So this is a metal version of a trap of some of the traps that we used in Tanzania. One of the other examples is the basket trap. So that's made from local grasses, and it's woven. So the Quelea enter the trap through the cone in the middle, and sometimes they can actually trap a lot of Quelea per day. And some of the traps or some of the harvesting techniques in Chad, where the habitat is a little bit more accessible compared to the average Quelea thornbush area, is always, most of the time, it is very encroached, so it's physically very inaccessible to control access the nests. And then those in Chad used fishing nets, which they quickly wrap over the trees where the Quelea are. They are then scared or frightened to fly into the net, and they can harvest. In the study by Muli, they harvested almost 1.2 million Quelea over a month period. So that can seriously, using novel techniques, can seriously decrease the Quelea population in a district, and thereby minimizing the effects of damage on the crops. This is Professor Cheek in action. This is a funnel trial, a funnel trap trial, executed and being constructed in Dodoma, close to Ndachi area. So this trap has a light box. So the light box has transparent glass at the top. So inside the box, there is a very, very bright light shining, and it shines through the funnel trap. On the next slide, you can see more of the dimensions. On the left-hand side, you can see the two poles are holding up the net. So it's going into a V shape where the net area becomes smaller and smaller. And you can see that the netting is almost invisible. So this is a view from the wide open mouth of the funnel trap into the box. So the idea is that Quelea, when they fly at night, when they are scared, or when they are chased away from the trees, they fly where they can see, and that's why the light is put in the middle of the trap. And then they fly into the sides of the net, and then they are concentrated by falling into the box at the end of the net. On the right-hand side, you can see the height of the poles. So that's easily 8 meters or so, and it is positioned in the area where the Quelea are. So there are noisemakers deployed around the area. So they all converge and making noises by drumming or beating cans together, or whistling or shouting, and that encourages the birds to enter the funnel trap. There are limitations to the funnel trap in that the more inaccessible the area is, the less easy it is to set up this system. Okay, what we've also seen with very, very high accuracy are people using the baobab rope slingshots, and they are very accurate at getting the Quelea. If they hit one, the rest of the flock flies away, and when they come back, the person is able to get maybe 50 to 100 Quelea in a day. So the Quelea are obviously a very, very high or highly nutritious food source. It is it's almost free of any fat, and it has high concentrations of protein and vitamins compared to beef. So it is a very, very highly nutritious meal or food source. Okay, when we're looking at alternative to fentanyl or pesticides, in the case of repellents, one needs to look at what is required for a chemical to be effective. So the ideal repellent should be non-toxic to humans. It must not be toxic to the environment. It must be cost effective, and it must be target specific. So that is the prime requirements. If one can get all of those characteristics in a chemical, that makes one win first prize. We ourselves have tested Measuron. It is a registered repellent in South Africa as a bird repellent on small grain crops. We have done screening trials on the captivity, and we have used different concentrations of methiocarbon treated seed in cages, and we did see a dose response curve on the higher concentrations, where a lot less of the seed was eaten, and it is an open trial, so there are different containers that we used with different concentrations of mesurable. But when the birds become starved, there wasn't a concentration even at 4 times the registered dosage rate. The birds also, fed on the methiocarbon treated seed. So the corollary to the field conditions is, as Quelea prefer grass seed to any small grain crops for most parts of the year, when weather conditions deteriorate the seed supply. So when those seeds are less in the field, grass seeds are less, they then look at alternative food sources like small grain crops. And it's Africa, specifically the winter millet and winter wheat, that have now caused, or has resulted in large portions of the Quelea flocks remaining and overwintering in areas. So the problem with that is that relates to a higher growth point for the next summer season. So the more Quelea that is left after winter, the faster the log phase growth will happen when the summer breeding attempts occur. So you're sitting with a higher population of Quelea in the small grain production areas. One of the chemicals that was tested by the Endangered Wildlife Trust is alpha chlorelose. It is a narcotic chemical, so that is intended to be used on bait. So that is coated seed that is put up or spread around. So, but the problem is, it is not specific to Quelea, so you do get non-target species coming in and also eating and also becoming sedated from that. So one has to be very careful to ensure that one monitors the situation, etc. I don't know how applicable it would be to large commercial farming areas where there are thousands of hectares under winter wheat. So, but it might be an option for the small scale to subsistence farmer field scales, so as a personal means of protection against Quelea damage. Methyl anthranilide is a non-toxic food additive. It is registered and currently used for protection of rice. It is totally non-toxic. It has a grape flavor, so it is used in foods to provide a fruity flavor. So it is given the all clear by the Environmental or the Food and Drug Administration in America. So it is something that one can consider. We don't know how well it will work for Quelea. If one sprays the wheat or the food source, and one of the drawbacks, even though it's non-toxic, it can be quite expensive to use on a large scale. One of the other chemicals that have been tested is 4-aminopyridine with various results. Aluminium ammonium sulfate, as well as aluminium sulfate on its own. Trimethacarb is similar to methiocarbon. It's also an organophosphate, and some studies have suggested using caffeine. So caffeine is readily available. It is not so expensive, but the results that studies have shown is that one has to use maybe in the region of 10 kilograms per hectare to get control or repellent effects. So this hasn't been tested in South Africa. It's something that we needed to look at, but there was not enough funding for that. One thing that we did test was different dilutions of molasses. That is your cattle feed molasses. We looked at the possibility that can be a disruption of the insulating surface of the feathers, also causing flight impediments. But the best time to do that, or the circumstances, or the scenario, is it has to be done under very cold conditions. So although day temperatures are relatively high in our small grain production areas in South Africa, the wheat to wheat in those areas, the night temperatures can go, between -4 and -8 below 0 degrees Celsius. So under those conditions, we've seen about 30 to 40% mortality of the birds, but the rate at which it needs to be applied, we looked at modifying an aircraft. An aircraft can only really apply between 30 to 40 liters per hectare, and we modified an aircraft. We had to go up to 160 liters per hectare. So that means one needs really, really strong pumps on an aircraft to do that, and you need an aircraft with a very large hopper in excess of 1,000-liter hopper to hold the amounts. So that's definitely a drawback. And the frequent landing and refilling of the aircraft would be required to spray. I think it has to fill up for every 4 hectares. And then one of the things is to look in literature for other alternative chemicals for repellent effects. I think it's something that the screening for needs to be continued. Okay, if we look at what would be the way forward, is to ensure that farmers always have a good agricultural practice, and that is especially the phytosanitary practices. That weeding is done properly, not to get the Quelea to eat, or to invite them to come and eat. Also, serious thought has to be given to alternative crops. So the one easiest thing would be to change the crop to a crop that Quelea don't eat, but that is easier said than done. In semi-arid regions, there's only so many different crops that one can grow, and it's certainly less of an option for subsistence farmers who need a staple crop with enough energy and nutrients to become food secure. There's been development in bird repellent cultivars, either with higher tannin content, but higher tannin content has a adverse effect on human consumption because of the bitter taste of tannins, but there are also repellent cultivars with differences in the spikes. It makes it more difficult for birds to eat and get to the seed. An option that is also put forward, that has been tried, is trap crops. Those are crops to lure the Quelea away from the main crop. Other options is looking at intercropping and crop rotation, so that Quelea this is not an area that will always have food for them during winter. And there's an area in South Africa, it's on the Springbok Flats, it's in the Mpumalanga province, so that area is ideally suited for spoil grain production. So that becomes a total hotspot during Quelea season in the winter months. So, and you're looking at almost 200 control operations that are carried out. Then evaluation of multiple strategies should be investigated further. That is combinations or integrated approach using repellents, bird scaring, and falconry. as I alluded to earlier, and the talk will follow just after this one. And then with new technologies like drones, not just optimizing it for repellent and pesticide application, but also for scaring. There has been an article looking at that and using drones that are on that looks has the form of raptor bird species, and also it can emit the noise of the fight or flight reaction in Quelea. One has to always remember that any of the alternative strategies must be easily implementable by small-scale farmers at the field scale to be effective. And I think in any advances under those scales of subsistence farming will have immediate positive socioeconomic feedback to those homesteads and communities, as the children would now be allowed to go back to school and be, continue with their socialization and integration. One of the options that have been studied quite extensively is using avian pathogens, but it has not been very successful or effective, as most of the avian pathogens are very non-specific, and raptors and other non-target birds seem more susceptible to those type of agents. But I think we need to look at agents that might be, if one looks at maybe epizootic diseases or maybe blood parasites, etc., further investigation could lead to maybe some positive outcomes. And also, what is crucial for an integrated approach to Quelea control is it needs to be community-based. The community needs to coordinate their activities. So when for instance, if a different planting date or earlier maturing crop is used, the whole community, the whole homestead needs to do that at the same time, in order not to have the Quelea or to prevent the people who do follow or plant earlier crops by someone in the district that don't, and that will cause the Quelea to remain in that area, and the effectiveness would be decreased. So that should be promoted community involvement. Right. And then I'd just like to say thank you and acknowledge our project leader, Professor Cheek, and then with the co-workers from FAO and from Botswana Ministries of Agriculture, as well as Tanzania. And all that left me is just to thank you for your attention. And I will be very happy to hear your comments and your suggestions. Thank you very much.